Welcome everybody. My name is Heiko Drewes from LMU Munich, Germany, and this is my talk on the Fitts law filter bubble. In 1948, Claude Shannon published his paper A Mathematical Theory of Communication, which later was called information theory. Information theory is built on solid mathematics and has relations to theoretical physics with which it shares the concept of entropy. Information theory is definitely hard science. Many scientists in many science disciplines were very happy. Information theory seemed to be universal. Consequently, many scientists applied the vocabulary of information theory to their field of research. One of them was Fitts, a psychologist who wondered in 1954 what limits the speed of a controlled arm movement, for example when pressing a button. The limitation could be the muscle force, hypothesis 1, or the information processing capacity, hypothesis 2. Fitts set up experiments where people had to hit a target of width W from a distance A with a stylus. Fitts varied the stylus weight, but participants' performance did not change. Consequently, he rejected hypothesis 1. For the second hypothesis, Fitts needed a measure for the difficulty of the task in bits, which he called the index of difficulty. There's information inaccuracy which is easy to understand when looking closer at a plotter, or laser cutter or 3D printer. If there are only 2 bits per axis to position the plotter pen, the pen can actuate 4 positions. In the presented figure, the 4 positions are not enough to hit the coin. If there are 3 bits per axis, the pen can actuate 8 positions and can now hit the coin. However, it is not able to hit a coin of half size. For this, it needs a further bit. This makes clear that there is a relation between the ratio of coin and plotter size and the necessary number of bits. Fitts defined the idea as the binary logarithm of a double ratio of distance and width. The doubling is necessary because the formula uses the target diameter and not the target radius. With Fitts' definition, the idea is 0 when the pointer reaches the target edge as the task is fulfilled. Every doubling of the distance from the pointer to the target center increases the difficulty by 1 bit. This sounds very reasonable. The index of difficulty is a value based on distances, which means it's purely based on geometry and there's no time involved. The time aspect comes with the assumption that it needs a minimum time b to process a bit. The completion time t is b times the ID. Fitts' experiments with different distances and target sizes supported hypothesis 2. Fitts' idea was reasonable, and his formula is correct. However, Fitts argued with Shannon theorem 17, a formula for the theoretical limit of the bandwidth of a channel. Shannon defined already on page 2, the channel is merely the medium used to transmit the signal from transmitter to receiver. It may be a pair of wires, a coaxial cable, a band of radio frequencies, a beam of light, etc. In contrast, Fitts wrote about the performance capacity of the human motor system plus its associated visual and proprioceptive feedback mechanisms. This is a channel. This is not a channel as there's additional power and memory, and if it's not a channel, Shannon theorem does not apply. In 1958, as a consequence of many naive applications of information theory, Peter Elias, a member of the MIT and president of the Information Theory Society, wrote his editorial, Too Famous Paper, and suggested to stop writing such papers. Unfortunately, Fitts did not heed Elias' advice and published a paper in 1964 with the title Information Capacity of Discrete Motor Responses, where he continued to argue with Shannon theorem 17 and prepared the ground for MacKenzie theory. In 1989, MacKenzie read Fitts' publication and understood its importance for HCI, as Fitts' law applies to clicking targets with a computer mouse. However, MacKenzie was not satisfied with Fitz's formula and wrote that Fitz recognized that his analogy was imperfect. This raises the question, where did Fitz mention that his analogy is imperfect, and what makes Fitz's analogy imperfect? MacKenzie argued that the two does not avoid negative IDs and that it needs a +1 to achieve this. Thus, he suggested a direct analogy to Shannon Theorem 17 for calculating the index of difficulty and introduced the A as intercept. As explained already twice, Shannon Theorem has nothing to do with an index of difficulty, and MacKenzie's analogy may be a little bit too direct. The figure shows the index of difficulty according to MacKenzie in green. The question is, why is there still some difficulty left when the pointer reached the target edge and the task is fulfilled? If the task is fulfilled at the start, the completion time is 0, and if the ID is positive, this means that the intercept has to be negative. There's a lot of confusion around negative intercepts in the HCI literature. In 1991, MacKenzie, together with Salen and Buxton, published a comparison of input devices in element pointing and tracking tasks, where they report about negative intercepts. Additionally, they claim that there is recent evidence that MacKenzie's theory is more theoretically sound. Scientists should not confirm themselves, and my question is, where is the evidence? The paper assigned the B parameter to the device, what later manifested a throughput in an ISO standard. In Fitz theory, the B parameter is a value of the performance capacity of the human. So my question is the B parameter a property of the device or of the human? In 2010, Drewes, this is me, published a paper titled Only One Fitz Law Formula Please, and questioned MacKenzie's direct analogy. However, the hope to stimulate a discussion in the HCI community did not come true. Instead, in 2018, Jury et al. Used my arguments against MacKenzie's analogy and turned it into an allegation against Fitz. Additionally, they upbraid Elias for urging authors to stop writing papers using information theory. Staying with Jury's metaphor of a funeral, it seems that the corpse buried by psychology stood up as zombies in HCI. With MacKenzie's theory, the HCI community was happy to have its own formula based on hard science and published many papers on the topic. With more than 20,000 citations of MacKenzie's work, it can be seen as an echo chamber. As reviewers demanded Fitz law evaluation even for eye movements, where Fitz law does not apply, it is also possible to speak about a filter bubble. Echo chambers and filter bubbles typically have narratives. The narrative is that Fitz did it wrong and HCI does it better. MacKenzie states that Fitz's formula is imperfect, and Jury even accuses Fitz of abuse of information theory. Also typical for filter bubbles is to ignore critique, to create confusion, and to keep the bubble alive. The last sentence in Elias's editorial about papers using the vocabulary and framework of information theory is, I suggest that we stop writing them and release a large supply of manpower to work on the exciting and important problems which need investigation. I think this is a nice, wise advice. Thank you for your attention.